So, good evening, dear participants. Welcome to a fresh session of this 1 month comprehensive bioinformatics workshop on data science and machine learning with Python and genome-wide association studies. So, we have with us today again Dr. Satyanarayan Rao. So, over to you, sir, for final session in this workshop of yours.
Thank you, Praveen. Let's get started. Everybody can see the screen, okay?
Yes, sir, it's visible. Your voice is also perfect.
Okay, thank you. So just want to confirm if everybody has this file that I shared with Praveen.
Sir, I have shared it in the drive link, workshop drive link in session 11 folder, and I'll also intimated on the group.
Cool. So I'm assuming everybody has this. So let's get started on a little bit more on pandas, and then we'll go into a NumPy and possibly SciPy. We'll see, but basically overall concept wise we should be kind of hit the fundamentals. So increase the font size. Oh, even more. Okay. Oh, there is no custom. 150 will be, I guess, too big. Let's see. Looking good. Shamesh. Okay. Okay, sure. So everybody can do this, I'm assuming. And let's, so the way I've given this file, yesterday we were talking about this wide format table and then long format table, right? And what we learned yesterday was, like pandas also have this box plot function, and it can actually do simple box plot, not even going into this long from wide to long format, right? So we'll just see how wide and long things work. So we first do import pandas as PD. Let me actually clear the perfect. So we just run pandas as PD, and then please read the file in this way. Let me know if everybody has this, otherwise it'll be hard to catch up. Can I get a couple of yeses? Cool. Yeah, so then we basically look, what is this? As I said here, a header is equal to none, because you have to see the file and see if they have headers. If you don't see header, then and put infer, then you are actually losing one set of information or one line of information as per se. So you have to be careful on that, right? So if since there was no header, I just said header is equal to none, and then said df. I just want to see what how the structure of the data frame is. So again, since you have said none, this is just zero based indexing, 0, 1, 2. But then given the data, I kind of know what kind of analysis I have done and what is the information I'm getting, right? So let's say I have this set of regions where I'm kind of analyzing from a particular let's say it's centered at some position, and then you have these offsets. Upstream is negative, downstream is positive. So it's saying that, okay, you're going from upstream like around 1,000 base pair, for example. Let's say if you have DNA sequence in the genome, then you are going 1 kb upstream, and then you're going 1 kb downstream if we do tailed, right? So this is how it is, right? I look at this number. We'll come to that why this is 10,004 and everything, but so this is the structure. But then it's also nice to actually assign column names, right? We worked a lot on indexing in the last session, but basically if we say, oh, I missed where. So Teddy, it's in the common drive link, as Praveen is saying. Praveen, could you please put forth? Okay. You should be able to access it pretty conveniently, I feel. Yeah. So now what we are actually saying here is we worked a lot on df.index, yesterday, like how do we actually assign the row names. A little bit worked on columns, but now we are actually kind of saying that, oh yes, you can actually assign column names in order. You see, the first one is offset, and then what signal we are getting and what are the conditions on which we are getting this signal, right? Is everybody able to do this? If I run this one and then I do df.head.
Satya sir. Okay. My doubt is, first you give your code, like first data import you like. So pd.read underscore scsb, that after that you give the path, I think. So how you do that? This is path you did along.
Okay, so wherever your Jupyter notebook is running, you have to put that file there. Otherwise you will get error. Sorry, not hearing.
If I'll keep my file is C drive, it's download, that will, if I'll copy paste that my path file, that will show the error.
I mean, it shouldn't. Ideally, it would be just that how the Windows convention in terms of the path is. Maybe you have to put like some kind of escape character to actually reach there. I can't kind of recapitulate what you're trying to say because it's a Mac system. But what I assume is could happening is like you have to say something like, I'll just say here, C, and then something like this. And then let's say user.
Okay, I did, sir. Actually, my question is like that. You did like long.tsv. This is maybe your path that can be. This is my question.
Yeah. So if I am to show, I'll just kind of.
And what is saved SCP and header was my question related.
Oh, okay. Let me first kind of resolve this issue. Isaac, you are not hearing me.
No, I'm able to hear, but that time actually what the problem is that what you're doing. I'm audible. Sorry, you are audible, sir. Actually, what is how you're just doing them? Also, I'm doing the copy paste. So that time I'm not able to.
So let me. So if I get your name, Surajit, or okay, if I like, for example, this is my folder from where I'm actually. Oh no! Shoot! I have to actually share the whole thing. Give me 1 second. I'll share my whole screen so that you can see things. So see, I'm running Jupyter from this folder, okay, where I'm keeping all my notebooks. So see, this is like my projects and basic Python, right? And I put my long.tsv here only, right? So my Jupyter notebook is running from here, from this folder. So your structure should be also like this, so that you can actually directly do this one. You don't have to go in the hassles of where the path is. Like maybe you just did like download and then it went to C and downloads, right?
Okay.
I would request you guys to copy that long.tsv to the folder from which you are running the Jupyter Notebook. I can take a pause for a minute because we will rely on this one. So I don't want to kind of lose you guys on that front just because of the unavailability of input file. By concept, there were questions on what is the significance of this separator. So sep means a separator or a delimiter in terms of computer language. And what you're seeing is whatever your kind of information is separated by. So as I was saying yesterday, then that you should keep this as your kind of a religion. Whenever you create file, you should be kind of a consistent on giving what separator you are giving. So let's say one column is separated by another by a fixed delimiter. For example, tab. You hit tab and then you write. You hit tab and then you write. That's how you define column. You can choose to do comma. So everything will be separated by comma. Okay. Okay, so I'm seeing it is in it is in the drive session. Okay, should I wait or keep moving?
So let me announce once again. So the data set shared by Dr. Rao has been uploaded on the drive link session 11 folder. I also mentioned it on the
I'll just wait 30 more seconds because this is important.
One query, one again, Satya sir. Actually, when I copy from the like my file was saved in download. I did what you did. I got it same as also. But before that, I saved my copy in my that file was long TSB the C file, C drive like that.
I see. Yeah.
Yeah. So I was keeping that. I did also same df. When I type the df.tel, the answer is not same like as you're showing like you.
Oh, really?
Before that. Yes, sir. That says the doubt. So that's why, yeah, sir.
So
this is now correct.
This
My answer is coming correct. Now the after going this code, what you doing in the code is like where I saved it. Yeah. As per your order, you have to keep it my file in where is my Python. But,
yeah.
But before
anyway,
that,
we can maybe something mystery is happening though. I can't probably know.
yes,
but
I was also wonder, sir, because
yeah.
how the result, because before is now very nice way is coming.
Okay.
One, yeah.
So we maybe we keep it on the side, that thing, and we move on. So now basically you have the data. We are now defining the column names, and you should be able to see this one now. Okay. And so this is in the long format. So let me just tell you the structure. Here we have in this condition, let's say you had 4 conditions on which you are getting this signal. So that is written by condition 1, 2, 3, 4. And then you also have some new observation, which is observed, right? And you want to say, you want to actually just visualize, oh, my observation is kind of similar to what condition, you know? So then you got the data, but then you have to actually look at, you can't actually say a thing just looking at the numbers, right? You have to do some kind of analysis. Even after you do analysis, you have to actually show visually, right? That's when this plotting and everything comes into the picture. Right now, what I'm trying to show you is this wide format. Like you can go from long to wide, wide to long, you know, like last time I showed you like melting. You melt it, then you get the long format. If you pivot it, means that you are standing on one and then you're just expanding, like you just kind of how can you say, you take one stand and then you kind of rolling it in a wide way, right? So that's kind of a pivoting. So you say on condition I want to pivot, and then these all will basically kind of get to the columns that you want to put. For example, if we do this, and I just want to show you how it works. So now what happened is you are pivoting on conditions, so they will become the rows, right? So we have 4 conditions and 1 observation, right? And then you're saying what should be my columns, right? So now you are having all these offsets going from -1 KB to +1 KB, right? Okay, it is just one base pair kind of off thing happening, but it's not of a big concern. Okay, but I just wanted to share with you guys, like, how can you actually go from one way to the other as per your convenience, right? So you use this function. Let me just copy paste here so that everybody can do this. Anyway, you guys will have the recording, but just in case of you want to, and let's say you you want to actually save this, you know, so then you have very nice function also available from pandas. Let's say you want to show it to your peers in this form, so you save that also, right? You can say so, but it's more kind of a yeah, you're right, it is doing transpose, but then you can get a complicated structure also. But anyway, you get that also in transpose too, but in principle, yes, it is the same thing. Yeah, we are doing that. Then you can actually save this, right? So there is a to CSV. So we were reading with read CSV. Then this is again one method. So let's say you say df wide, that you have this data frame now and you want to save this, then just say to CSV, you put the file name, and again, as your religion goes as the delimiter, as tab, and then you want to say that, okay, my index, you see now here the index is what? Conditions. You do want to save this, right? Because you want to keep that information. And header you can basically ignore, because what is header right now is this guy, this signal. So you will have like two kind of two, what do you say, two kind of a header, right? Like you are doing it like signal is something that has been flattened, right? So like the offset has been flattened, but what you get also is on the top of it these identity of these things as signal, right? So it's a little bit weird when you say header is equal to true. I'll just show you how it works. When I say header is equal to true, then you see you see the first column is just signal, first row is just signal, which is weird. What we are interested in is the offset, right? Then basically we just say header is equal to false, right? And then we see how it looks. Now you're just getting condition 1, condition 2, and something like that. It's a wide format, so it's a little hodgepodge, right? Somebody said mine is error. Rakesh Saroj.
Yes, yes.
You have error just reading this file?
No, sir. This offset wala.
Offset one.
This not df wide wala. Yeah, this one.
Really?
Copy. Yeah, really. I don't know, sir.
Did you do this one? Because this one is important. This one is
important. No, I haven't did. That's why I haven't did, sir.
Oh, so you didn't do this one. Let me just give you this because the name has to be there, because here we are using name.
Because I think so you like up too early. That's why I'm able to do codes.
I see. The font is actually bigger, so you are seeing very less of a content. But it's okay. So now I showed you functions like how to save, but now let's come to the real deal where we have we are gonna do the plotting, right? So there are many ways to do. In principle, there are 2 ways, or let's say 3 ways. You can say the core is called matplotlib, right?
So question is that like you is okay. You define the columns by the name. 3 columns:
Yeah.
offset, null, and condition. After that, you did the pivot. For why we need to the pivot this table?
Oh no, this one is just for the illustration. Last session, I was trying to explain that you can have table in 2 different forms. You know,
Yes, yes.
One is in like wide format and one is in like long format. Some people may be like, let's say you want to show it in like Excel, and your target is to convince people that, oh, you want to see the changes here. Maybe in the wide format is it better visible.
Yes.
And in long is more like your thing probably, like, oh, you want to kind of manipulate the data or work with the data, which can work nicely in the long format than in the wide format. So you just tune it in that way. But maybe in terms of representation, maybe that will be wider will be better. Imagine, let's say you have 3 by 50 matrix, right? So 50 kind of columns you can show nicely in Excel, but when it becomes long, then you have just like 150 long kind of very long column, right? Maybe that will not be very convincing, and you will not be able to color them nicely, right? That's when basically a pivot will come handy. Let's say you got some information and then you want to actually color code them in the long format, right? That's where this will come handy. But right now, this is not so much of interest in terms of plotting and everything. I just wanted to show that, yes, you can do this way. Okay. So we were here, and I hope everybody can do this one, import Seaborn as SNS, because this comes as a default in Anaconda. Let me know if anybody has errors in this one. Or I would like to hear a couple of yeses so that I can proceed. Cool. Okay. Okay. I think everybody should be able to have this one. Yeah. Yeah. So I was saying that matplotlib is like a beast, right? And there are APIs, more convenient kind of to the users, are written on top of that. Okay, so everything is kind of spawning from there. But the thing is, matplotlib is very kind of verbose. Like you have so many parameters, like you have so much freedom to do all the changes. But sometimes you actually don't want to go into all this nitty-gritty. Maybe if somebody has cooked something for you which is looking nice, then basically oh, okay. I think since we are just discussing, it's okay. Let it actually run, and let me know if you run into any errors. Yeah. So like you can go like matplotlib examples, scatter plot or something like that, and you can have many kind of examples. And this is very widely nicely documented. Okay, so you see, things are very nicely looking here. But my point is that I should be able to give you some idea on how these things work, and that basically you can build upon that easily, right? One wrapper is Seaborn, and basically, as I was saying, that if some it is kind of like a half cooked or 80% cooked thing, you take and you just kind of customize it. You put a cherry and everything to serve, right? So that's basically Seaborn, and it gives you a lot of convenience on how to plot things, right? For example, now what we have in this data structure is 4 conditions, and you're getting signal as these offsets. So we want to see in terms of lines how our data is looking, right? So the way we do it is, first we basically import. I hope everybody is able to do this, as I already heard yeses from you guys. So then we say SNS dot, and then things will pop up here. Why it's not coming?
What do you do in second line, 12 number, coding number 12, sir, before import SNS?
Oh, this one. Oh,
Yes,
so now here you are just seeing in the Jupyter notebook, right? You can save this white, like let's say you want to present it to your peer, right? So you save this into in a file, right? So this is the 2 CSV. You see this? Here we were doing read CSV, right? And now it's 2 CSV, means we put that whole data frame into a file, right? So that's what it is doing. So you put the file name, and then you put the separator, how the columns will be separated. And then you say index is equal to true. Why we do it is because we have the index now as conditions, and you want to actually keep them as your first column so that you can point it out, you know. And header is equal to false. I kind of went through that because if you put true, then you get first line as just signal. We don't want that, right?
Kind of, sir, coding we need to win, like all of you have to do like this df underscore white to CSV. Yeah, based on data, sir. How will do that? Why we need to this?
Oh, so you see, if, I would say that in the process of when you are analyzing your data, right, it is not a thing that you will always finally just present the result. There are intermediates which will be helpful in actually explaining the project to other, or even to yourself, like how the data has been flowing, right? So you may actually need at any point of time, oh, I want to actually save this intermediate file to see how this whole process has actually been occurring, right? This particular step is basically in terms of visualization, right? You will have, like, let's say, hard time explaining, oh, what is the value? For example, let's say you have 4 conditions, right? It will be hard to, let's say you want to mark minus 998 offset in all those conditions. Imagine doing this in a long format. You put this one as red, and again you have to scroll down like 1000 lines to actually find this guy again, right? How will you show that to your peer? It'll be very hard to show this color. Let's say you want to actually color them with the red. But now if you actually make it wide, then you can actually point this whole column, right? You're having everything here. So there are different purposes, right, of doing this. Long format probably will be very useful when you are actually trying to plot, and it is for you, for your convenience. Maybe for presentation purposes, this will be better, you know. So that is why I'm just explaining what kind of functions in pandas are available to actually save these intermediate files, right? Does that make sense?
So that dot,
Mm-hmm.
that the format, the name of the file, then dot to CSV. That dot there.
Yeah.
Can you explain? Is that the
Oh,
format?
so yeah. Dot is something. Okay, I think I went through this couple of many times, but let's see. Let me repeat. Whenever in Python you are writing a variable, or like every variable is basically object. Let's say if you say a is equal to 1, 2, 3, right? Then a is an object, and for object of a class, right? So then basically when you say type, it's more like a object oriented programming. Let me pause a little bit here. So type of a is a list, right? So it is coming from that, and then if you say a dot, means you're accessing the methods of that a list kind of a class. How will you know what all I can do is saying with dir a? You see, there are so many things here. Actually, these things you can simply access. You see, append, clear, copy, count, extend, index, insert, pop, remove, reverse, sort. All you can do with after pressing the dot. Okay. So when you say a dot, you see you're getting those guys, right? You will not get these guys. They are some kind of a magic functions. I don't want to go in that right now, but let me just give you just a simple recap. When you say a into 3, okay, what will happen? It happens like this. But you could say, oh, Dr. Sandeep has this error. DF wide. I'll come to that. Let me just kind of work on this one. So when you say a into 3, then maybe you were thinking of, oh, I wanted actually 2, 6, and 9, right? But it's not doing that, right? This is something called operator overloading. So what it is doing is when you say dir a, then you have this multiplication. So it's basically overloading this multiple sign that, okay, in list people actually most often want to use that, oh, I want to repeat things. Okay. So repeat is more important here in usability of this list than actually multiplying. Because for multiplying, people can take this effort of doing this list kind of a comprehension, right? Like I into 3 for I in a, right? Then you get 3, 6, 9, right? So this is something that Python has decided to actually work, kind of decide on what operator I will overload, right? It is doing something else what it's supposed to do because of the use in the field. Okay. So again, let's just focus on basically visualization a little bit more today. So yeah, dot is basically telling you how can what all the methods you can actually access. So once you do dot and then you hit tab, then you can actually access all the methods that you can apply to. And when you don't know what it does, you just put a question mark and then hit enter, and it tells you what all it can do. These documentations are comprehensive, but of course you have to take the pain of understanding all this. My target is to actually give you access to these and also let you kind of give you a headway to understand how to read these guys. Okay. Oh yeah, sure. Let me, Dr. Sandeep, are you able to actually do this one now, or still you are having problems? If not, then I move further. Okay, sure. Let me just. I hope you did. I mean, it has run till there, so it should be fine. Yeah. Okay. So where were we in terms of this import CBON and SNS, and then we want to see how the signal looks, right? So let's do this. Let's do a simple one first. I want to remove this guy. Keep it somewhere. Yeah. So here I just want to show you guys how this thing actually works. I will comment this one. I don't want to save this right away. And see, so now whenever you are plotting, okay, you should first look at what is the x-axis, what is the y-axis, and then you actually look at the data, or you should be able to first explain what is the x-axis and what is the y-axis. Here I kept a very simple name called offset. So 0 is your is the reference point. 0 is your thanks Sandeep. We can do that later. I want to continue a bit more. So we have this offset going from -1000 to 1000, and then we have the signal, right? What is our observation is actually first one, blue in color, as you are seeing that this is running in waves and it is hitting the tipping point here, right? And the condition 1, 2, 3, 4 are these lines, red, magenta, green, and then orange, right? So what you can say, like if I am to ask what is the observation closest to which condition, right? Then what do you guys think? Definitely not condition 1, right? Because that signal is pretty different at position 0. Do you guys agree? Any couple of yeses or nos, so that yes, Surajit, yeah, something like that, right? So now this is the power of like plotting, right? You are seeing things, and you can actually dictate now or kind of more confine your kind of visualization and look at the data more detail. Oh, I'm interested in these offsets now, subset of these offsets, let's say -250 to 250. That's when all these ideas comes in, right? What is happening in those regions, right? So that is the idea, right? Visualization color scheme is so much important in visualization, is like you can't really imagine how important it is, right? So aesthetics gives you the feel that how much you actually have worked on looking at your data and explaining your data, right? So I would highly encourage, if you guys are not aware, then you should use Color Brewer. Are you guys aware of this Color Brewer? Any yeses, nos?
No, sir, please explain that.
Okay, so yeah, so this is a little bit off topic, but it's also important in terms of visualization. What color brewer is, it gives you this what do you say, a spectrum of colors which clearly distinguishes your data points, okay, or your groups. For example, let's say you have diverging, let's say you have sequential data, then it will be something like this, right? Lighter to darker color, right? If you have diverging data, then it will just give you different kind of a color scheme, right? If you have qualitative data, it gives you very different colors, you see? So let's say if you have 6 kind of groups, then you actually can pick these colors so that your visualization will be much nicer to actually explain, oh, this is my group which is in green. Sometimes it's very hard to find all these colors by yourself. Color Brewer gives you this very nice capability to kind of choose these colors, you know. For example, here, as you're seeing, this diverging means it is going from darker to lighter on one end, and then it is picking another color from lighter to darker, right? Yes, I will do that. Like, how do you link color to notebook, right? There are, for example, here there is an export thing, right? You can actually get a list of these colors, right? So you just copy this and then you actually work on it, right? But the core thing, you get it, like all these hex codes, right? And then you can actually put it. For example, let's say I'm interested in four of that, right? Let's say if my conditions are in sequential manner. Let's say you are using some drug, and in condition 1, 2, 3 are like more intense levels of drug you're putting in, right? Then I can take 4 of these colors and observe. I can keep another color, right? So let's say I took from here to here, so 3 of these I take, right? And no, 4 of these actually, sorry, 4 of these, right? And then actually let me just go through that, okay? That's why I disabled it earlier. So you put observe is equal to red R is just red, okay? And then I have these 4 colors, right? I can just keep on putting it here like this. We are going from lighter to darker, so maybe I just put lighter to condition 1, right? Condition 1 as not blue, but this, right, with the hash, right? Similarly, condition 2 now is like this. Condition 3, this one you need to little bit work manually just to set the stage for the color to appear, right? And then condition 4, sorry, this is not Python related, but it is also important. Okay. So then you actually, now you have defined your own palette, not taking the default of Seaborn. Okay, so that's where the advantage comes in and your effort basically looks. So here the Python gives you this, oh no, notebook is not visible. No, I was doing on some, sorry, I should here. So let me basically, so palette is an option where you can say what colors I want for what variables or what groups here, right? So I'm saying that observed is red, condition 1 is this color, condition 2 is this color, something like this. You see what is happening here, you are putting as a dictionary. Let me just make it more nicer here so that it's better visible. You see, I would strongly motivate you guys to use dictionary when you're doing palettes, because can anyone give me the reason why we should use dictionary? There is option for using list also, but I encourage you guys to use dictionary. Why? Any answers?
We'll give the option, I think.
Pardon?
Option will give.
Option? Yes, assign keys, right? Now you exactly know what color you actually gave to the variable. In list, it may be sometimes, oh, what is the order, you know? So here is like exact mapping. You can move this guy down here, doesn't matter, you know? Like, let's say if I move this guy up here, down here, doesn't matter, right? Because it is a mapping, right? Now, if I do the palette, now how beautiful now it is looking, see? You don't have that much of a divergence, or like your eyes are not getting, oh, what is all this? What is all this? R is basically short for red. You can just say red also, right? It will work. Okay. Like if you're like RGB, you know, those shorthands will work. So those are basically just kind of proxies to. Oh, PLT is not defined. Oh, really? Did you do? But anyway, if you are getting that error, let's just do this one. Let me copy, put this one matplotlib. I'll just copy this one here. Sorry, I wonder why this one is coming, but not going into the debugging mode right now. We want to move further. Looking good now? Okay, perfect. So yeah, where were we? This one, not really. Okay, yeah. So we practiced line plot now, right? How about if you want to do box plot or something like that, right? So here, just for the kind of illustration purposes, I've not given any file. We'll just work on it right now to prepare the box plot, prepare the data also, and then we just visualize it. Okay, we'll prepare just some synthetic data set where we will then use NumPy to actually get the data. Okay. So let's kind of ignore this one right now. So here, NumPy is a library which actually gives you a lot of where you can actually do a lot of numerical operations. For example, often when you're doing analysis, you run into matrix form of data. right? You run into like you want to basically do a big matrix addition, big matrix multiplication or something like that, right? Or if you have a single array of data, let's say a list, and then you actually want to multiply or square it or something like that, right? The NumPy has tons of those kind of functions which can help you actually do your analysis. For example, if you want to generate some distribution, you can do that with NumPy. For example, we'll just learn it here. The very first kind of distribution you kind of learn is normal distribution, right? So it is actually, so we first import this NumPy as NP. That's the standard convention. You import pardon? Oh, somebody was saying something. Oh, anyway, I move further. So what we are now doing is we are generating data by ourselves. For example, let's say you have some gene X, okay, and you put two conditions, and then you are actually doing, let's say you have this liberty of generating 100 kind of technical replicates or biological replicates, right? Then what your data point will look like, replicate 1, replicate 2, replicate 100, and you are observing expression value, okay, for that gene X. Let's say, since we are generating the synthetic data, we'll say it is in condition 1, the expression was around 5 following the normal distribution, right? So what we are now doing here is NumPy, then in this random, right, in this random module, you have this normal function that can actually generate normal distribution, okay? For example, what we are seeing here, let me just give you the np.random. I haven't run this one. np.random.normal, right? And then we look at the help here. So location is actually mean, scale is standard deviation, and how many points you want. Okay, what it is doing? Draw a random sample from a normal Gaussian distribution, right? I hope I can take it. I can take it as, like, you guys know, normal distribution. If not, let's just assume that we are just generating random number of points for that particular gene in condition 1. Okay. So we just run this. Let me put this one here. You want to just look at how the values look like in case of normal condition 1 dot head, maybe let's say 50. Oh, it doesn't take this. Oh, it's not a data frame, sorry. Condition 1, 0 to 30. Okay. So as you can see, the data is actually centered around 5, right? If you take the mean, you see the 5, right? So it's just generating random number, but with the mean of 5 and standard deviation of 1, right? Now we are generating again the expression of the same gene X, but in condition 2 you are having high expression, right? So we get this condition 2 expression, right? So can we now create a data frame from these condition 1 and 2? What will be the syntax? Here we say pd.data frame, and as we were doing last time, you create a dictionary, right? That is what we are doing. Key value. We know that the size of these conditions, the number of replicates that we generated are the same, 100 in each, So we know that the length are actually exactly the same, right? So it will not throw error, right? So in condition 1, we had a list of expression values, and in condition 2, we had a list of expression values. So now we can actually create a data frame with this, right? So when we look at any questions on this one, I want to take a pause a little bit here. Yeah, there is one. Rahul. Is it generating random numbers based on file DF? No. It's there is no DF concept here. It is just random. You see, there is no DF data frame, that long.tsp or something that we read. This is totally different. It is just random numbers, right? Because I'm trying to kind of this kind of a plot is different. Oh, did I go through saving the figure? Oh, I didn't. I should. Sorry for diversion, but you can actually save. Oh, because it will be around 5, okay, because it's random, so you may get 5.5 or 5.2 or 5.3, something like that. Don't as you keep increasing the number, like, oh, you might have, like, if you say condition 1 dot mean, it will get closer probably. We are not generating a lot of number. Copy paste the code of colors. Yeah, sure. Here you, maybe I just give you this one, or maybe whole is better. Okay, cool. So yeah, so we were here. See, we are only generating 100 points, so you will be around the mean. If you generate 1000 points, let's say, for example, I just want to kind of, it will get closer and closer to 5. You see this? That's the behavior of like normal distribution. More the number of samples you have, more closer it will get to the mean. That's the law of large number is in the concept of mathematics and statistics. We don't want to go in there, but we just, for the sake of simplicity, we just generated 100 points in condition 1. In condition 2, we have 100 points, which created a data frame here, and then so we want to actually look at expdf, take a sneak peek. 1 to 5. So as you can see, in condition 1 we have this, and condition 2 we have higher expression. But now we want to annotate, like here it's like an orphan, you don't know which gene was it, right? So you always want to actually tag it with the convenient names on which your data is. Even though you know it is for gene X, it is better to put it in the frame itself so that it is always intact. Okay, so we take the burden of introducing another column, gene name, and I just put gene X. What is happening here is, this is just like in our, it's just borrowed from our, for the people's convenience. If you just put one thing, it will keep on repeating, right? Because you can argue that it is not 100, right? But you put one, if it is just one, it will just it assumes that you want to actually repeat this guy, so it just put that, right? You can also say something like this. This is where list comes in handy. You can say this and 100. It will not complain, because this is gene X 100 times, as you had this condition 100 times, condition 200 times, right? Is this clear to everybody? This is where you are actually understanding this operator overloading, right? So what we got now is, when you look at expdf.head, you have this gene name, although it is like the same name, right? Now we want to do the box plots, right? So we have done this before, but anyway, I'll just run it. So now what we want to do is, in Seaborn, it's something like you want to put X and Y. So X is basically on X axis, your conditions will be there, and your Y will be the values. But our format right now is not that way, right? Our columns are actually condition 1, 2, right? But X is something that you put it as one column, you know. So that is why we melt. I'll explain what maybe it is sounding complex right now, but once we melt it, as I was explaining yesterday, then we look at melted.head. You always get 3 columns, right? The one on which you are melting, you are making this long table. Now your variable is actually condition 1 and 2. They will keep repeat. This will repeat 100 times. Condition 2 will repeat 100 times, and in each of this condition 1, you're getting that value, right? So now you only have 3 columns. This is the long format, and Seaborn is much comfortable with this. It will not complain anything. You will get the way you want your actually box plots, right? Can we? Yeah. Here, okay. You have questions on this one, like why it ran, didn't give any error? Shefi? It gave an error. Oh, okay. Interesting. You have this one running. Can you do this on line 40? You have to first run this guy. You should be able to get this one. Let me know if you're able to. Okay. It's not gene X equal to 100. It's like multiplication. You see, what I'm telling here is that repeat gene X 100 times. Okay. You could also just keep it gene X and it will also work, because Panda assumes that, oh, you actually, I give you this freedom that, oh, you want to actually repeat this guy, I will repeat it for you. Okay, you don't need to take the pain of multiplying the list 100 times and giving it to me. Okay, so those kind of freedoms you have, you can basically exploit those, right? But let's get back to the melted version. So now every time you melt, you only get 3 columns. Now what we have to do is we just have to do the box plot, right? So we'll just go through this now. I want to first take a minute here and explain how matplotlib works. I'm just giving you a simple explanation. There are many things you can do. It's impossible to cover in a session or even in 5 sessions. Okay, but matplotlib has very nice documentation. What I'm saying here is, give me the figure as an object, and then this AX01 and AX02 is basically a pointer to how many panels you have. For example, here I'm saying that PLT is the object, PLT is the module that you just kind of defined here, imported, right? PyPlot, right? So you're saying that give me the subplots, basically a vector or a matrix of panels, right? And what is my design of those panels is actually set by rows and columns. So here you're saying this 1 row and 2 columns. So basically you're saying that a wide like 2 panels, horizontal panels, not a vertical one stacked, right? Horizontally stacked. So you are saying 1 row, 2 columns, and the first panel is pointed by AX0, second panel is pointed by AX1, right? Then what you want to say is, again, we are going back to this as we were doing SNS.line plot. You see this? We were just doing SNS.line plot. We could similarly do SNS.box plot, right? So I'm not doing any magic here. We're just calling the function of the Seaborn. Okay, and then I'll copy paste the whole code, but I want to explain you guys how it works. right? So as I was saying that everything has kind of spawned from matplotlib. So SNS is again the wrapper, right? So you see there is a mixture now. You are calling matplotlib, you defined your structure of the plots, they are all empty right now. Then you're filling the meat in with the plots that you want to put it, right? So what I'm doing is in AX0 means the first panel, I want to say that my data is melted one, this guy, right? And then I'm saying that X is variable. Now tell me what will be on the X axis. I have two conditions. So condition 1 will come and condition 2 will come as like condition 1 and then one box, condition 2, another box. That is what I'm meaning to say, right? So I don't have to write condition 1, 2. I'm just saying variable and take that as a category and spread it out, okay, on X axis. Y is the value, because you just take all the values in condition 1 and put it on the Y axis. Similarly, you take all the values from condition 2, put it on the Y axis. And hue is basically the color scheme, like which one right now they were just putting the values in, right? You didn't say any colors. Let's say you thought of now putting colors to those conditions. So you can say color hue is equal to variable. So it will just go to this variable column and determine how many categories do you have. So I only have two conditions. So it will pick two colors default, right? But then if you define palettes, then it can actually, as we just discussed in the line plot, you can customize that with your own kind of a feel and look, right? So that's how we can actually do the box plot. But important part is many, let's say you Google it, right? You will not get this guy, okay? You will have like, they will just say, oh, data melted and do this, right? But sometimes your needs are like, when you're going in a publication level figures, you have to actually organize them, right? So how can you do it in the code? So you have to basically do it this way and specifically say that this box plot should go here, this box plot or line plot should go here. Now you have independence of whatever you want to do, and then it will put it there. Maybe we'll practice that right away. We'll put box plot in one and a line plot in the other, okay? So what I'm doing right now is just putting the same thing in both the panels. So when I run this, what is happening here is you are having this condition 1 and condition 2, and then you are having X is basically variable, as you said here, right? And Y is the value, and then you are having the data plotted very nicely. Let's say if we make it 2 by 1, I'm just going to explain how it works, then it'll just become like this. Let me now copy paste this whole thing. I'll do it with the 1, 2 so that left right makes sense. Because other one becomes top bottom. But anybody have any questions? So we are at the time now. I didn't even have time to go into the NumPy, but I guess you guys can pick it up in case of in NumPy. I thought visualization is something important, and I wanted to spend time on how you actually get this. So let's is everybody able to run this? I want to hear a couple of yeses, and I want to spend 1 or 2 minutes to put the line plot in here, okay? EOL while scanning string literal. Interesting. Are you sure you copied everything? Because it could be possible that this whole block has not been copied. Meanwhile, I'll try to actually put this line plot and see if we get this right. This is my honest attempt. Let's see if it works. We'll just say AX is equal to AX1, right? And we'll disable this guy. Okay. See, magic. Can you explain 1, 2 again? Oh yeah, Surajit. 1, 2 is defining the layout of your panels. You see, 1 means number of rows, 2 is number of columns. So 1 by 2, so 2 panels in 1 row. So basically wide horizontal figure like this right now, left and right. If you put 2, 1, so you want 2 rows and only 1 column. So that will be like something like maybe line plot will look nicer when we put 2, 1, as you're seeing right away here. You see this? So again, it comes to your look and feel, right? And you can play with all this aesthetic. There are many options to put the legend outside and play with those. Those things you guys can explore. We are running over time, but my aim was to actually explain this one. This is really important. Many people miss out on actually giving this hint, or like giving this guideline, right? This gives you really the freedom to how basically do this, right? NumPy, there are many things. For example, let's just spend 1 minute. As we were doing A is equal to 1, 2, 3, right? And we saw when we do A into 3 is like this, right? Now let's do A is equal to NPA is equal to NP dot array and A. Okay. And then when we say NPA into 3, then you actually get 369. So, you know, again, so basically Python is telling you, I have many things. Please read me and explore me to utilize what you want. Okay. If you have the list, you may well settle with this kind of a function utility than this one. If you want to do this, you better actually define it as NumPy and then basically work on that. The melting part, yeah, sure. Oh, you meant this one, I guess. Let's see. This is for the box plot one. Yeah. Sorry, 1 hour is too less. But yeah, this is what it is. I can put couple of NumPy thing in a notebook later and share with you guys. Praveen will share. But I guess you guys have gotten the hang of how to use Python and how to actually get your hands dirty. That's more important. You can Google it. The idea is that you should know now how to Google and what to Google. That's more like that gives you the results quickly, right? That's the whole motivation, because this is very evolving language, you know. And there is, as I was saying, there is no shame in Googling and learning. Okay, it's totally fine. I guess that'll be all, Praveen.
So,
excuse me, sir.
Yeah.
Sir, please explain the last code where you import the numpy dot. Yes, sir.
Yeah,
as
this
INV last code 57.
Oh, okay. Oh, so this is just a toy example of doing inverse. You know, let's say so you have linear algebra. Okay, there is another module called linear algebra in NumPy, and you can actually take inverse kind of a function from there, and you can simply inverse a matrix. You see that. So these are the things that are there, and basically enables you to do many things depending on your need, right?
So before signing off for today, any participant want to say something to Dr. Satya, as this is the last session of Dr. Satya in this workshop. Definitely we will invite sir again in our workshop, but if anybody want to interact something, they can interact by unmuting themselves. Otherwise we will wrap up this session. And Dad is saying thank you, sir.
Oh, thank you, thank you.
Uh,
Sir, your explanation was very good. And
Okay, thank you.
you
thank
know,
you.
from the first day I just started learning this, I am very new to this. But now I'm thinking that I know the basics, so I can learn more. Thank you so
Yeah,
much.
that was the whole goal, you know.
It was very good, really wonderful session. All sessions.
Very nice. I mean, I'm glad. I kind of yeah. Thank you. The whole idea was that to you guys get your hands dirty and you're comfortable with coming on Jupyter and writing. You know, sometimes you have this block. Oh, what will I do? Kind of unlocking or like getting rid of that block is the whole thing. Rest is you, and you are exploring everything. So
and and thanks, Dr. Rao, for sharing your experiences with our participants, and we believe our participant enjoyed your sessions also,
I hope
and
I gave.
they are expressing uh, it in the chat box.
Yeah.
So uh, thanks, and I will share this Python notebook and video recording of Dr. Rao with you.
Yeah.
As
I'll
soon
try
as-
to add some more NumPy things. Sorry, I couldn't get to that. 1 hour is like too less.
so,
But
so,
yeah,
Could you
so
please give your mail ID if you don't mind?
uh, for doubts and everything, or because I don't know if I will be able to kind of respond. The questions you can put it on the
Google Doc.
Google Doc. Yes.
So
Yes.
I've shared the Google Doc with you.
Yeah. Please
So
put it there. As I see the time and
so 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 we'll keep it. We will keep the Google Doc live for a 1 or 2 months. If you have any problem,
that will be actually more productive than going through individual emails.
yeah,
Right?
and it
Yeah.
will be a record. It will be a record of
Yeah.
your query, so that
Yeah.
some participant having some same type of query can also have access to that problem.
Yeah.
So you can also write to us.
I mean, I'm not is kind of chickening away from giving my email ID. The only thing is that my life is really going crazy because of I'm looking for positions, and you know how it is. And like we have a baby, and she's just 1 now, and she's just driving us like oh my god, it's very hard to manage time now. So apologies on that. I am not that type of a guy, but it's just that time is really kind of holding us.
So thanks, Dr. Rao, and we also thank you from bottom of our heart for making this workshop wonderful.
I'm glad I could help, you know.
And uh, there is also an announcement for our participant. Kindly note that the Python based project will be scheduled after machine learning sessions. Okay, so tomorrow's session is postponed. We will share the latest date with you. Okay, so tomorrow is off, and kindly note this change in schedule. And our next incoming module is Python, that is machine learning with Python. So Dr. Salman Sadullah Usmani will deliver sessions on this machine learning with Python, and Dr. Mishra and Dr. Rao has perfectly set the stage for incoming module.
Yeah. Thank you.
So with these
Hope
words,
it's that
now
way.
I seek permission of Dr. Rao for ending today's session, sir.
Yeah. Thank you.
Thank-
Yeah, sure. Please
Thank
put the
you.
questions on Google Doc. We'll try to answer it. Sorry, in Silico has been asking many questions. Please put it on the Google Doc.
So, and also after putting in Google Doc, simply message me. I will forward it to Dr. Rao. Okay, thanks and goodbye.
Yeah, please close it. Yeah.